Hello and welcome to part 2 of the series for the toughest M1 questions or toughest mechanics questions. In this series, I'm trying to solve different questions with non-typical ideas for you guys to check out. Alright, so we have the question in front of us from Jan 24. It's question 6. It's a kinematics question. So let's attempt and try and read it. So it says that a particle is projected vertically upwards from a point A with speed 24 meters per second, and says that point A is 2.5 meter vertically above point B. So if this is point B, then point A is vertically above B, and the distance between them is basically 2.5 meters. So he says that the particle and B is horizontally on the ground. So this is the ground where B is. So it says that the particle is projected vertically upwards from point A with the speed, let's call it UA, with a speed of 24 meters per second. And let's just call it U, not UA. Okay? So let's continue reading and let's see what does the question want. The particle moves freely under gravity. I know that the acceleration working here is the acceleration due to gravity until it hits the ground at B with a speed v. So I'd expect this particle to go up and then go down again until it reaches the ground. Okay, and when it reaches the ground, it says that it's going to be moving with a speed v equals the speed is basically speed unknown, which is v meters per second. Okay, after hitting the ground, the particle does not rebound. So probably no momentum equations needed here because it didn't tell me any rebound, any collision, nothing happened. So the first question tells us to find the value of V. Okay, so since this is a kinematics question, what I like to do, as I showed in the previous video, and by the way, I will leave a link for the previous video. You can click on the top right corner to access that video. So how I try to approach kinematics equations is by writing every letter, okay, and in front of each letter I'm gonna write the equation that doesn't contain this letter. So the equation that doesn't contain S is V equals U plus AT. Similarly for A, it's S equals V plus U over 2 times time. For V, S equals UT plus half AT squared. For U, S equals VT minus half AT squared. And for T, it's V squared equals U squared plus 2AS. So let's see, what do we have here? We want to find the velocity after this particle is launched and brought back again. So some people, what they like to do is they like to divide this into two sections. The first sections, they take it when the particle moves until it goes up and stops. Okay, so V is 0. That's the first part. And then the second part of the equation is when it starts to move down. Okay, but I like to work with it as a whole from start to finish. So this is my starting point, this is my end point. A is my starting, B is my end. So let's see, what do we have? We have U as 24 meters per second, and I'm taking, in this example, I need to denote that I'm taking down as positive. So I know that my U is acting upwards, so it's going to be a negative value. And A, I know that my acceleration is acting downwards, so it's according to the positive direction that I've assigned, so it's going to be a positive 9.81 meters per second squared. S is 2.5 meters below A, so it's also a positive value. And V is basically what I want. So from this equation, the only letter that I didn't mention was T. So I will come back to my table here and very easily just choose the equation in front of T. Why do I do this? Because in kinematics we have 5 equations. This is a systematic way to show you how to choose which equation to use. So I will do the question as V squared equals U squared, which is minus 24 squared, plus 2 times acceleration, which is 9.81, times S, which is displacement, which is 2.5 meters, And if I want v, I will just square root all of that, and this will give me an answer of 24, square root of 24 squared plus 2 times 9.81 times 2.5 is going to give me an answer of 25 meters per second, and it's a positive answer as expected. Positive means down, so I'd expect the velocity is in the downwards direction, and this is the case over here. Okay, so this is the first question. Let's read part B. Part B says, find the time taken for the particle to reach B. So the total time it took to reach B. So in order to do that, I will again use my Suvat equations, okay? However, this time I don't want V, I want T. So what is T? I don't want to use the V that I calculated because it's a calculation. So I might be having an error here, and I don't want this error to be carried to the next question. So whenever I can, I will try to use the givens only. And this is a very good approach that you can implement. So I have U, A, S, I want T. So the only thing I didn't mention was V. So I will very easily use this equation. So S is 2.5 meters downwards equals UT. My U is negative 24 times T plus half. A is 9.81 downwards, so it's positive, and I have a T squared. I will see that this is going to be a quadratic equation, so 9.81 divided 2 is basically going to give me a 4.9 T squared minus a 24 T, and then I will move this 2.5 to the other side. It's going to be minus 2.5 is going to be minus 2.5, and this is going to equal 0. So from here, I will solve this as a quadratic equation. I can use the quadratic formula, so I will use minus b, which is 24, plus or minus square root of b squared, so minus 24 squared, minus 4 times a, which is 4.9, times c, which is negative 2.5, all over my 2a, or 2 times 4.9. This is going to give me two answers. The first one is going to be plus square root of 24 squared minus 4 times 4.9 times negative 2.5 over 2 times 4.9. This is going to give me an answer of 5 seconds and another answer of negative 0.102. So obviously I don't have a negative time, so I will disregard this answer and I will take t equals 5. So for part B, t equals 5 seconds. Okay, let's continue for C. So it says that point C is 10 meters vertically above A. Find the length of time for which the particle is above C. Okay, this is an interesting part, and this is the hardest part of this question. So it says we have a point C over here, which is 10 meters above point A. Okay, so 10 meters above point A. So I need to know that it says, and in the question it tells me find the length of time for which the particle is above C. So that means that my particle is going to launch, reach C, and then move and continue back down until it reaches the floor. So what I want is basically the time period. Let's do this. So what I want is basically the time period for which this particle was above C. So what I can do is, I know that my u is 24 meters per second upwards. I know at point C, my displacement is going to be negative 10 meters because I'm taking downwards as positive, and the displacement is above this my starting point, so I can take S as negative 10 meters. And let's see here, when will my particle have a displacement of negative 10 meters? This will occur at 2 times. The first time when it's launched and it first hits C for the first time ever, okay? And the second, so this is the first time, and the second time when it moves up and comes down exactly again at C, okay? or if it's moving in an upward motion, this is not a projectile, this is moving up and then falling down. So if this is C, it's gonna move the first time when it reaches C going up, and then it goes up and comes down again, it will reach C again. So basically, what I'm trying to say is that it will reach C, or it will have a displacement of negative 10 meters at 2 different times. If I got those 2 times, I can subtract them from one another to know how much was the particle above C. So let's start try and do that. So for part C, what do we know is that U equals negative 24 meters per second. I know that my A is pointing downwards as a 9.81 meter per second squared. And I know that I don't know my V, I want my T, and I know that my S is negative 10 meters. This is the shortest and the best way to solve this question, because there is another way. You can find the time till it reaches C, find the time till it reaches this zero part, and then find the time when the velocity is zero, so when it's moving, changing from movement upwards to downwards, and then find the time from here to here and add the times. But I don't recommend this method. What I'm saying is better. So let's check which equations we can use. So we have U, A, T, S. I didn't mention V, so I'm gonna use the equation above in front of V. So S, so S, which is negative 10, equals UT, which is negative 24 times T, plus 2 times A, which is 9.81, no, plus half, sorry, plus half times A, which is 9.81 times T squared. So solving, I'm gonna have a 4.9 T squared minus a 24 T, and then moving this 10 to the other side is gonna become a plus 10 equals 0. I can solve this again using quadratics, so it's gonna be negative B plus or minus square root of B squared, so negative 24 squared, minus 4 times A, 4.9, times C, which is 10, over 2 times 4.9. This is going to give me two answers. How do I get two answers? When this is plus at the first time and when this is minus for the second time. So the first time is going to give me an answer of T equals 4.45 seconds, and that second time, or the second answer, is when let me just check. This is 4.9 minus 24, 10, yes. So, and the second time is when T equals 0.46 seconds. So this means that particle will be at a displacement of C. So if this was A, C is here, the particle will be at C first after 0.46 seconds have passed, and then again when this whole thing basically is 4.45 seconds passing. So if I want the time that it's above C, which is what the question wants, I will need to do 4.45 minus 0.46, and this is going to give me an answer of 4.45 minus 0.46 is going to give me an answer of around 3.99 or 4 seconds above C. I hope everything is clear, and please, as always, if you have any questions, you can send me the questions down below. So let's continue to solve the final part, which says sketch a speed time graph for the motion of the particle from projection to the instant it reaches B or reaches the ground. So it says a speed time graph, not a velocity time graph. So we know that speed is scalar, so it doesn't have a direction, so no minus and no plus. However, when I was talking here, my u was negative 24 because here I'm talking about velocity. But here we need to draw a speed time graph. So let's see how are we going to do that. So let's draw our y and x axis. So this is the speed in meter per second, and this is the time in seconds. So first of all, I had a speed of, okay, let's take, just for the sake of the graph, let's take the speeds upwards as positive, okay? So we started with the speed of 24 meter per second, okay? So we started with a speed of 24, okay? And then the speed decreased, okay? The speed kept decreasing until the particle hit its maximum displacement and stopped for a while, okay? So this speed decreased, okay, for some time, until it reached the highest point, and then it started to move down increasingly again until it reached V, where we calculated V in the first part of the question as 25. So it continued moving upwards with the same, they should be, by the way, because the acceleration is the same, then their gradient should be more or less the same. So around here, let's say this is 25, this was at B, and this was A. So this is supposed to be your speed time graph. Anyways, please let me know if you, and all this, we know that all this took around 5, so this is, let's erase this. So this all took around 5 seconds, and this is t in seconds, or let's make it t. Okay, so basically this is the answer to this question. Please, if you have any questions, leave them down below. Don't forget to like, subscribe, and please stay noted for more questions. I'll be doing more M1 questions, and I'll be starting to do also pure 1 and 2. So stay tuned for that. Feel free to ask any questions, and thank you so much for watching.